On the forum, we've discussed about the. I put a thread about the formation of complex numbers, how they start, how complex numbers were formed. It's quite abstract. Okay, the first link is based on that. Basically, complex numbers deal with roots of a negative number. You can say, how do we get a negative number? Okay, the concept of negative numbers is quite abstract. Because usually, when you study maths, if you were in a full maths student, you ask the teacher, why do we study maths? He or she's going to tell you, okay, for example, if you need to pay money to count things and all that. But the concept of negative numbers can't be grasped at that level. But when you do Form 3, you start to understand negative numbers. Because negative numbers is related to the concept of debt. Okay, because you owe someone money, so it becomes negative if you try to add the numbers. Okay? So that's negative numbers. Now, complex numbers, usually we use that to describe a physical object. A physical object is in two dimensions. If you take a picture frame, you've got the length and the width. So what you need to keep in mind is every time you're solving a variable, the variable can be a two-dimensional object, simply. Okay, so when you can't find a real value, maybe it is an unreal value, maybe it's a two-dimensional object, simply. Okay? Now the application of complex number deals with physical objects having two dimensions. Okay? You can have a look at the application of complex numbers online. Okay, you've got a link where it explains to you where do we apply complex numbers. Okay? But complex numbers deal with something called imaginary numbers. Okay, it's represented by I. By definition, I squared is -1. Okay, and I is root of -1. Okay, you guys know the real number line. Okay, the real number line contains numbers which can be positive or negative. Okay. These numbers, we use them to relate. We relate these numbers to quantities, usually. Okay, I owe so much money. I have $2, $3, or I owe $2 or $3. Okay, so we relate these numbers to quantities, but you may have a number which is two-dimensional. So real numbers are found on the real number line. You may have a number here, or a number here, which is two-dimensional in nature. Okay, so that's a number. And we said 1, that's a number Z2. We'll see later that complex numbers, they are usually a combination of real numbers plus something here, the second axis, which is called the imaginary axis. So a complex number is a combination of a real number and imaginary axis. Because I told you that the complex number is a two-dimensional parameter. Okay? This board is a physical object. So that's one dimension, that's the second dimension. So if you're solving an equation having x, and the x represents the dimension of the board, so it's not a real number, it's a variable representing the dimension of the board, which is two-dimensional, so that becomes a complex number. Okay, so that's an easy way of understanding complex number. So every time you solve, maybe you're dealing with a complex number, a two-dimensional variable, because you don't use variable only to represent quantities, but to represent two-dimensional movements also. Okay, you studied vectors now. Oh, equation of a line. Or it was a plus lambda b. It was a two-dimensional object. Okay, because it was a point on the grid. Okay, R was here, so R represented a movement on the x-axis and y-axis. So it was a two-parameter variable. Okay, so that's where we use complex number. That's how we can define complex number. Anyway, how do we get root of a negative number now? Got an idea?
If a quantity has a direction as well, and you need to find the square root of that quantity if that direction is negative.
Yeah. Once again, we're talking about movement. So what you're saying is this: if you've got a point E, you move forward. That's plus 2. If you are moving backward, minus 2. So that distance, it's a negative distance. So while doing calculations, you may be having roots of a negative number, only because of the concept of E. Okay, because in proper diagrams, you need to relate a movement to a certain point. So if you've got E, if you move forward from E, it's plus 2. If you move backward from E, it's negative 2. So the negative number doesn't mean negative distance, it only means that you're moving backward from a certain point. Okay, so the negative sign helps us to locate points on a grid relative to a certain point. Because when you draw, if you just say plus 2 can be anywhere. Okay? Because if that's point A, that's point B. If you say, I'm not going to use negative numbers, how are you? And I tell you, B is 2 units from O, so where's B going to be situated? You can't really say. But if you say negative 2, you know that you're moving backwards. So the negative sign helps us to plot points on the grid. Okay? If you want to understand how they work with negative distances, you've got a link on the geometric interpretation of complex numbers, how they really work with negative numbers. It's quite abstract because you've got only letters in that link. But if you plug in numbers, you try to work out the examples, it's okay. You can understand it. Okay? But understanding complex numbers is outside the scope of the syllabus. You're only meant to work with the numbers. Okay? But the application of complex numbers is very vast. You use it in electrical engineering, mechanical engineering, computer graphics. Because computer graphics, you've got movement once again. Okay, so the variable represents two dimensions. Okay? So by definition, you know that I squared is minus 1, so I is root of negative 1. Okay? So I squared is minus 1. If you need to find I cubed, you're going to do I squared times I. Okay, I squared is minus 1, so minus 1 times I, you get negative I. You work out I4. I4 is I cubed times I. I cubed is minus I times I, you get negative I squared. And I squared is negative 1, so you get positive 1. Okay? Why we did that? I did that only to explain to you a certain pattern that we see when we multiply by I. I take number 1, I multiply by I here. I get I. And multiply by I again, I get I squared this, sorry. That's I cubed, that's I4. I multiply by I again, I multiply by I again here. So I take number 1, I multiply by I get I. Take I multiply by I again, I squared times I cubed times I4. And you see that I4 is 1. Again, so we get back to the initial point. Okay? So 1 times I times I squared, which is minus 1. I squared times I cubed, which is negative I cubed times